Hello, here is a passage containing question from 12 to 14, and the write-up says, consider a setup shown in this figure. It says which uses right-angled prism to transmit horizontal ray. This device is known as anamorphic de-magnifier. During its passage through the prism, the ray experiences TIR twice, then exits as shown. So it's coming horizontal, then go TIR, then again TIR, then refraction coming outside horizontally. The prism is made of a glass of refractive index mu. There are questions 12, 13 and 14 we need to talk about. So question number 12. It says if the emerging ray propagates horizontally, which of the following is correct expression for refractive index? So let me redraw this picture, or let me explain this redrawn picture of ray diagram having geometries as well. So this is h1 height from the base where the light ray is entering and entering at this point. So here it's going to be undergoing refraction. Since incident angle is 0, then you'll find refracted angle is also going to be 0. That's the simplest point, but I'm explaining. It goes directly inside, undeviated, then falls on this boundary. At this boundary, refraction would have might have taken place, and reflection both together. But question directly says that here it undergoes TIR, total internal reflection, no refraction. So it turned out to be in this direction. Now, since this angle theta is given as a theta, so this is going to be theta because horizontal and the same line. Then the angle of incidence for this TIR is going to be 90 minus theta. And we know the same angle is going to be angle of reflection. So this is coming like this. Then you'll find this entire angle was 90 degree because normal, this is a normal at A. So this is going to be theta because this was 90 minus theta. Moreover, you'll find these are alternate angles, so you'll find this is also theta. So we have made these angles. Now this light ray falls at B location, then we need to have a normal. So this is normal, and angle of incidence we need to catch. Then you'll find if we produce this line which was initial, and this will be at 90 degree, and this total angle we just identified as a theta and theta, that is 2 theta. So this is going to be the remaining of the angle. That means it's going to be 90 minus 2 theta. So for the second time TIR, the incident angle is 90 minus 2 theta. Of course, this is going to be 90 minus 2 theta because TIR, total internal reflection. Then at C point, light falls and undergoes refraction, which is again horizontal and at the height h2 from the base. So here we can think of this is the normal, and this is the angle of incidence for this refraction at C. Moreover, this horizontal outgoing ray can be produced backside. So you'll find this angle is going to be this alternate angle or whatever you call it as a. So this is going to be theta, and entire was 90. So this is going to be 90 minus theta. And if it is 90 minus theta, so that means emerging angle, or we can say refracted angle, is 90 minus theta. We got to know. Moreover, this angle is going to be 90 because normal is there. We are worrying for this angle I. Now you will find this angle was 90 minus 2 theta, and this is going to be 90 because right angle triangle. So this angle must be 2 theta, very important. And since this is 2 theta, and we can also say this is horizontal line, this is the original inclined of the prism, so you'll find this angle is also theta. So this entire angle turn out to be 3 theta. Now you see this entire angle up to this normal is going to be 90 degree, and we got to know these two angles sum is 3 theta. So I will be found out from this figure. So this figure is very important, and based on this we will be answering for 12, 13 and 14 questions. Now in this case we can say the thing that I just explained, that theta plus 2 theta plus I must be 90. Theta plus 2 theta plus I must be 90 degree. That means I must be 90 degree minus 3 theta. This is by using the figure. Now using Snell's law at the last refraction at C, so you'll find mu into sine incident angle is equal to 1, which is mu of air sine r. Mu we need to find out. Incident angle is 90 minus 3 theta. Refracted angle we just talked about as 90 minus theta. Sine 90 minus something is equal to cos that thing. So that's come out to be mu cos 3 theta is equal to cos theta. So mu turn out to be cos theta divided by cos 3 theta. And you'll find there's an option which is D that will be representing this expression. So D is the correct answer. Moving ahead for 13th question, which says the range of the dip angle theta, that means angle of the prism, for the device to work as whatever it is meant to be. That means anamorphic de-magnifier. So that means these things has to be taking place. What? The TIR at A, TIR at B, and refraction at C. Now you'll find incident angle for A is 90 minus theta, incident angle at B is 90 minus 2 theta. Of course 90 minus 2 theta is going to be smaller, and we know for TIR to take place, incident angle should be greater than for a particular angle, critical angle. So point is, if this 90 minus 2 theta is beyond the critical or ahead of the critical or more than the critical, then this must be more than the critical, of course. So if we ensure that TIR takes place at B, it must be taking place at A for sure. So that's write-up is over here, you can check it. And we know critical angle can be calculated as mu sin theta c is equal to sin 90 into 1. Then you'll find sin theta c comes out to be 1 by mu. Now TIR at B becomes very important, because TIR at B will ensure TIR at A as well. That means 90 minus 2 theta, whatever this angle is, this must be greater than theta c. For ensuring TIR, greater than, not equal to, right? So it's greater than, right? So we are making it clear. Now take sin theta on both sides. Sin theta is increasing function, so if thetas are more, sin thetas are more, right? So you can, it's going to be sin 90 minus 2 theta is greater than sin theta c. Sin theta c is 1 by mu. So that's 1 by mu. And that becomes cos 2 theta greater than 1 by mu. But cos theta is like a decreasing function between 0 to 90, right? So you'll find it's going to like 2 theta should be less than cos inverse 1 by mu. Now you see this was greater than, cos theta was greater than. However, 2 theta is come out to be less than. Why? Because cos function is decreasing function, whereas the sine function is increasing function. So whatever the relation or inequality goes with the theta, same goes with the sine. However, in cos it is opposite. Anyway, you got it. So theta comes out to be less than 1 by 2 cos inverse 1 by mu. So this is one condition for theta to be. Another, it should be ensuring refraction at C. That means at C there should not be TIR taking place. That means incident angle, whatever we have calculated so far, this incident angle should be less than critical angle. And then you can again apply the sine. So sine I is less than sine theta c. I is 90 minus 3 theta we know, and sine theta c is 1 by mu we have calculated. So this turned out to be cos 3 theta must be less than 1 by mu. That means 3 theta must be greater than cos inverse 1 by mu. That means theta must be greater than 1 by 3 cos inverse 1 by mu. That means ultimately theta should be greater than 1 by 3 cos inverse 1 by mu and less than 1 by 2 cos inverse 1 by mu. This is the range of value of this dip angle that you are looking for this object to work as anamorphic de-magnifier. That means option D is correctly saying the same range, hence we will mark it. And then there is the last question of this passage, which is 14th. It says ratio of height of incoming ray from base of the prism to that of the emerging ray is defined as the vertical de-magnification ratio. Vertical de-magnification ratio. Which of the following is correct expression for the vertical de-magnification ratio? Now you see the figure again. This is H height, incident 1. This is H2. It is talking about the ratio of these two. However, the language is a little bit, or we can say we need to correct it. It should be like H2 by H1 we are looking for. So H2 by H1 is de-magnification ratio. Anyway, so what we can do, we can use that geometry which was shown here in the figure as well. So this is, we consider triangles. So let me explain. We are considering triangle ADB. So ADB, this is A, this is D, this is B. This triangle need to be considered. Now in this triangle you'll find this BD is going to be H. This BD can be related with this hypotenuse, and this is right angle triangle, right angle at D. This angle is 2 theta. So we can use this sine 2 theta, because sine 2 theta will be using this D as well as like DB as well as this AB. So that's what have been done in this. Sine theta, sorry, what we have used need to be checked. So we are looking for this DB and this AB. So this is going to be base, this is angle 2 theta, so it has to be sine. So sine 2 theta must be BD divided by AB. So sine 2 theta must be BD divided by AB. Good. And BD is H1, so H1 divided by AB. Now from here we can write H1 is going to be AB sine 2 theta. Similarly, triangle BEC has to be caused. So BEC, let me explain. This is BEC triangle, this triangle. This angle is again twice theta. This is 90 degree. This is base. And we are looking for this BE. B is going to be equal to H2, height. And this BC. So we can say sine 2 theta is going to be BE upon EC. Sine 2 theta is equal to BE upon BC. BE upon BC. And BE is H2, so H2 upon BC. From here, H2 can be calculated as BC sine 2 theta. You can make the picture at your copy and you can check it. From these two relations, you'll find if we divide them, then H1 by H2 comes out to be AB divided by BC. So AB and BC ratio we need to find out. Now how to get AB BC ratio? For that sake, we can consider this triangle, which is ABC. We require AB, we require BC. So we can use sine rule. AB divided by this sine 3 theta, BC divided by sine theta. So that will be the sine rule. So AB divided by sine 3 theta, BC divided by sine theta. So that turn out to be AB divided by BC as sine 3 theta divided by sine theta. Now if we are looking for H2 by H1, so that will become BC by AB, BC by AB. So BC by AB will become sine theta divided by sine 3 theta. So sine theta divided by sine 3 theta, that will be the ratio of heights, or we can say vertical de-magnification ratio, which is mentioned at A part. Of course, so B part is not going to be the answer. Now there is a C and D part. They are in terms of mu, not in terms of theta. And mu in terms of theta we already know. So we need to manipulate and check whether we can get these kind of expressions. So let's consider this thing, which is sine theta upon sine 3 theta, with basically H2 by H1. Basically that's what we are looking for. Now we can write it as sine 3 theta comes out to be 3 sine theta minus 4 sine cube theta. Now divide this by sine theta, so that turn out to be 1 divided by 3 minus 4 sine square theta. Now this 4 sine square theta could be, sine square theta can be replaced as 1 minus cos square theta. So if you replace it as 1 minus cos square theta, then 3 minus 4 will lead to minus 1, and minus will become plus, so plus 4 cos square theta. Now we want to take it in terms of mu, and we know the mu value is in terms of cos theta, cos 3 theta. So we need to bring cos 3 theta stuff. So for that sake, what we can do, we can add and subtract 3. So or if we bring like minus 3 over here, so we need to have a plus 3 as well. So plus 3 and this minus 1 will become plus 2. So it will become 2 plus this number, and this number can be multiplied by upside and divided by as well cos theta. So by cos theta multiplying, it will become 4 cos cube theta minus 3 cos theta divided by cos theta. Now if you will look carefully, then you will realize that this is expression for cos 3 theta. So it turned out to be 1 divided by 2 plus cos 3 theta divided by cos theta. Since mu has been calculated as cos theta divided by cos 3 theta, that means it's 1 by mu. So it turned out to be 1 divided by 2 plus 1 by mu. You can cross multiply or simplify this. That turned out to be mu divided by 1 plus 2 mu. And there are two expressions, so D expression matches. That means this height ratio that you are looking for is also mu divided by 1 plus twice mu, so D. So finally we will get A and D as our response. But there's one point to catch. This is the ratio of height of emerging ray and to that of the incident ray, because we are calculating H2 by H1. So here answer will become A and D. This is how we have completed this passage, which contains question 12 to question 14. Thank you.